So we're going to continue our discussion last time. So let me begin with the following problems. Finding derivative of piecewise functions without using one-sided derivatives, no? Using limit definitions. So let's say we're given f of x is equal to x squared plus 1 if x is less than or equal to 1, 2x if x is greater than 1. We are asked to find f of x, f prime I mean. So how to find f prime of x without resorting to left and right hand derivatives, limit definitions, no? So first you check if the graph of y equals x squared plus 1 and the graph of y equals 2x at x equals 1 connected. Okay? So meaning f is continuous at x equals 1. So that's the first thing that you have to check. So continuity of f at x equals 1. So what are the things to be checked, guys? You need to check function value at 1. And we know that it is equal to what? 2. 1 squared plus 1, no? Which is equal to 2. And this happens to be the limit also of f of x as x approaches 1 from the left. What about limit of f of x as x approaches from the right? So that is equal to 2 times 1, and that happens to be equal to 2 also. So hence, we say that what, guys? F is continuous where? At x equals 1. So meaning, possible that f prime at 1 exists, na? And but we are looking for f prime of x, so for any x. And of course, we need to check if it is differentiable at 1. So let's now proceed. How do we differentiate f? So using the first expression, what's the derivative of that? 2x. So if x is less than 1, no? What about if x is, if y equals 2x, what's the derivative? So that is 2 if x is greater than 1. Now, at x equals 1, f is continuous, but is it differentiable at x equals 1? How will you know? Find the value of 2x when x is 1. So meaning the derivative of f when x is less than 1. But let's check if x is 1. 2 times 1, is it equal to 2? Yes. What about the second one? What is f prime of 1 kapag to second expression ang ginamit natin? X is equal to 2. Since the value of the derivative at x equals 1 sa first dito, sa first, so sa derivative here at sa derivative sa pangalawa here, pareho, so we are going to include 1 in the domain of the derivative. Okay, guys? So that's now the derivative. And it is differentiable at where? At x equals 1. And at any number to the left of 1 and to the right of 1. Okay? So if x, let's say, is not differentiable at 1, you're not supposed to include in the domain of the derivative. Let's have number 2. So this is the answer here. So given f of x is equal to x squared plus 2 if x is less than or equal to 1, x plus 2 if x is greater than 1. Find f prime of x. So meaning the derivative at any x, no? But this is a piecewise function, so you have to be careful. Again, let's check for the continuity of f at x equals 1. What's the function value? At 1, we have 1 squared plus 2, that is equal to 3. And this is also the limit as x approaches 1 from the left of f of x, right? So what about limit as x approaches 1 from the right? So of f of x, no? So we use x plus 2. So 1 plus 2, and that is equal to 3. Okay, guys? So what did we get, guys? Are they equal, the function value and the limit, guys, at x equals 1? Yes, no? Or as x approaches 1? So hence, f is continuous at x equals 1. Possible that the derivative exists at x equals 1. Okay? But we are not interested only at x equals 1, but in any other number. So getting the derivative now using differentiation rule, let's apply it to the left of 1. What's the derivative? 2x. So that is if x is less than 1. But about when x is greater than 1, we have simply 1, right? So if x is greater than 1, let's check the existence of the derivative when x is 1. So if x is equal to 1, so using 2x, 2 times 1, that is equal to 2. What about using 1? When x is 1, what's the derivative? 1. Are they equal? No. Therefore, we are not going to include 1 in the domain of the derivative. Okay, guys? So this means what? This means f is differentiable at what, guys? At every x in the set of real numbers except where? Except at x equals 1. Get it, guys? While the first one in number 1, f is differentiable at any x. Okay? So yung number 1 means f is what? That f is differentiable at any real x. Okay? Okay, guys?
Yes,
and actually, number 1 is differentiable on the interval negative infinity to positive infinity, even on the interval, and at every number in this set of real numbers. Okay, yeah? Did you get that? But yung number 2, differentiable siya at any x except at 1. Okay? Meaning yung graph ni derivative, if you're going to graph the derivative, not connected saan? Sa 1. Kasi magkaiba yung value niya. May jump discontinuity yung derivative, ha? Pag ginarap mo yung derivative. Iba ang graph ng derivative sa graph ng function, ha? Okay? Is that clear, guys? Let's have the last one. Here, number 3. Given f of x is equal to x cubed plus 1 if x is less than or equal to 0. It is 1 over x if x is greater than 0. Okay? Oh. Find f prime of x. What is the derivative of f at any x? So let's see. And restrict it, of course, if it is not okay at 0. But if it is okay at 0, you have to include also. Is that clear, guys? First, we have to determine if the graph of y equals x cubed plus 1 is connected to the graph of 1 over x, y equals 1 over x. How will you know? So you check the continuity at 0. Okay? For the continuity of f at x equals 0, what is the function value, guys? At 0, 0 cubed plus 1, 1, no? And this is also the limit of f of x as x approaches 0 from the left. Am I correct? What about limit as x approaches 0 from the right, guys? It is positive infinity. So it means f is what, guys? What does it mean? F is discontinuous at x equals 0. So automatic, it's not differentiable at 0. Got it, guys? So you do not have to include 0 in the domain of the derivative. Get it, children? What's now the derivative, guys? Guys, 3x squared. If x is to the left of 0, I don't include 0, huh? Guys, because it's not differentiable automatic sa 0 because it is discontinuous there. Meaning, the graph of x cubed plus 1 and the graph of 1 over x in the xy plane not connected at 0. What about the second one? Negative 1 over x squared. So that's the derivative of that. So instead of using limit definition, one side derivative, easier now to get the derivative. Am I correct, guys? But if you are asked of one-sided derivative, you have no choice to use that. But if not, you can use this solution. Clear, children? So the derivative is okay at any x except sa 0. Oh. Anong interpretation ito, guys? F is differentiable where, guys? F is differentiable at what? At all or at every x, no? At all x except what? Yan. Except yan. At x equals 0. Okay? Yan. So meaning, at what? At yan. At x, element of negative infinity to 0 but open, union with open sa 0, positive infinity. Yan, differentiable at all x in this interval. Okay? Get it, guys? Kapag ang function differentiable, it is continuous there. And if it is differentiable at any number, it is continuous on the entire real line. Okay, so let's now have higher derivatives. Exercises on higher order derivatives. So let's say we're given y is equal to 4x cubed plus 5x squared minus 7, asking for y triple prime. Okay, how to find the third derivative? First, we have to get the first derivative. Differentiate the first term. Simple power times constant, 12x squared. Simple power times constant, 10x. Derivative of constant, 0. That's the first derivative. What about the second derivative? So that is 12 times 2, no? So 24x plus 10. What about the third derivative? That is the derivative of the second derivative, no? So simply 24 because we have for the 10, 0. Get it, guys? This is the third derivative. Number 2, let's say we're given f of x is equal to 4 over, let's say, square root of 2x minus 3. What about the second derivative of f? To get the second derivative, first, let's rewrite the function in terms of power form, no? So f of x is equal to 4 times 2x minus 3 raised to negative 1/2. Taking the first derivative, drop the exponent, multiply by 4, so negative 2. Copy the base, subtract 1 from the exponent, getting negative 3/2. Then derivative of the base, 2. So simplifying this first derivative, we get negative 4, 2x minus 3 raised to negative 3/2. What about the last derivative, which is the second one? What's the second derivative? Derivative of this first derivative. Again, negative 4 multiplied to the exponent. So that is 6, no? Then times the base, subtract 1 from the exponent, negative 5 over 2 minus 2 over 2. So derivative of the base, 2. Get it, guys? Finally, we have f double prime of x is equal to 12 over 2x minus 3 raised to 5/2. What about number 3? Given f of x is equal to x to the 100. Find 100th derivative of y with respect to x. If you're given a problem like this, so it means there is a pattern. You do not have to get from y prime to 100th derivative really manually, no? So find a pattern, no? Notice that the exponent is 100, asking for 100th derivative. So find a pattern. Find a pattern. Let's check for smaller powers, no? So let's say I have y equals x. What's the first derivative, guys? 1, no? What about if I have y equals x squared? What is the second derivative? First derivative is 2x. Second derivative is 2 times. Anong derivative ng x? 1. Do not multiply out immediately because you will not see the pattern. What about if I have y equals x cubed? Asking for the third derivative. Y prime, 3x squared. Y double prime is what? 3 times 2x. What about y triple prime? Are you now seeing a pattern, guys? 3 times 2 times 1. Are you seeing a pattern, children? Can I now write the answer? What is the 100th derivative, guys? What do you think, guys? 100 times 99. times 98 all the way to what? 3 times 2 times 1. Am I correct, children? Guys?
Yes, sir.
And what is this number or product? There is a compact way of writing that product. 100 factorial. Get it, guys? Number 4. Y is equal to x over x plus 3. Okay, find y triple prime. Oh, what is y prime? The denominator, derivative of the numerator minus the numerator, derivative of the denominator, all over the square of the denominator. Simplifying, we have 3 over x plus 3 quantity is squared, or that is, or rewriting further, I am just rewriting 3x plus 3 quantity is negative, no? Exponent. What is the second derivative? 3 times negative 2. Copy the base. Subtract 1 from the exponent. Get the derivative of the base, 1. What about the third derivative? We have positive 18. Negative 6 times negative 3. Copy the base. Subtract 1 from the exponent. Get the derivative of the base, 1. Or finally, we have, pwedeng yan, or the positive with the positive exponent, x plus 3 raised to 4. Oh, get it, children? Guys? Okay, so number 5. Given x squared plus y squared is equal to 4. Find the third derivative of y with respect to x. So we apply implicit differentiation, no, to get the first derivative. By implicit differentiation, guys, differentiate the left, differentiate the right. 2x plus 2y, y prime equals 0. Divide by 2. Solving for y prime. Negative what? X over y, right? What about the second derivative? The denominator, I will copy first negative. The denominator, derivative of the numerator, minus the numerator, derivative of the denominator, that is y prime, all over the square of the denominator. Okay? But what is y prime? But y prime is equal to negative x over y. So therefore, we have negative y minus x times negative x over y all over y squared. Get it, guys? Times y here over y, so that we will able to eliminate this fraction in the numerator. What do we get now, guys? Y double prime is equal to negative numerator, first term, y squared, plus second term, x squared, all over y cubed. But if you notice, x squared plus y squared is equal to what, guys? Is equal to 4. Look at this given. What is x squared plus y squared? Equals 4. Therefore, I can still simplify this second derivative into negative 4 over y cubed. Am I right, guys? Children? And this is what? Negative 4y to the negative 3. What is the last derivative? Which is third derivative? Positive 12 y to the negative 3 minus 1, magiging negative 4. O, tama na ba yan o may multiplier pa, guys? Guys, do I have to multiply something pa? Guys? Children?
Sure, by y prime?
Y prime. Kasi we're differentiating relative to x. So times y prime, derivative of y prime. But what is y prime? So 12 times 1 over y to the 4th times negative x over y. Am I correct?
Yes,
So
sir.
finally, what is y triple prime? Negative 12x over y to the 5th. Oh, that's it. Number 6. Find the second derivative of x cubed y cubed minus 1 equals 0. Ay minus 4. Find the second derivative. Oh, how to find the second derivative? Guys, we differentiate each side, no? Getting, that's product, the first derivative of the second plus the second derivative of the first. Derivative of negative 4, 0. Right side, 0. Simplifying, we divide by what? Divide by x squared. Am I correct? Ano pa? Another x squared. Am I right? So getting 3x y prime plus 3. Pwede pa rin yung 3, no? Times 3. So we get x, y prime equals, plus y na lang. Tama ba? Divide, may natirang dito, may natirang x, wala nang y. X na lang, y prime. Tama, no? Patapos sa kabila, y na lang, no? Wala nang x. Okay? Yan. Equal 0. Or what is y prime? Negative x over y. Am I correct, guys? Or y over negative x? Y over x, negative, na? Second derivative. Negative. Quotient. The denominator, derivative of the numerator, minus the numerator, derivative of the denominator, all over the square of the denominator. But what is y prime? That is y over x, negative, no? So y double prime therefore is equal to negative x times negative y over x all over, yan, pero meron pang minus y, no? All over x squared. What is y double prime, guys? Negative of negative y minus y. Tama ba? Guys? Yes. And then, finally, what is y double prime? 2y, positive na, no? Over x squared. Okay? Do you have any question with that? No more.